Hi, good afternoon, ladies and gentlemen. It's my honor to introduce Professor Bill Laurance for this next talk. So, Bill Laurance is a distinguished research professor at James Cook University in Australia, and also holds the Australian Laureate Fellowship, one of Australia's highest scientific awards. He is the director of two major research programs and organizations, the Center for Tropical, Environmental, and Sustainability Science at James Cook University, and ALERT, which is the Alliance of Leading Environmental Research and Thinkers. So he is also the a fellow of the American Association of the Advancement of Science and the Australian Academy of Science, and the former president of the Association for Tropical Biology and Conservation. He has received many scientific honors, including the BBVA Frontiers in Ecology and Conservation Biological Awards, a Distinguished Service Award from the Society for Conservation Biology, the Heineken Environment Prize, and the Zoological Society of London's Outstanding Contribution to Conservation Award. So Professor William Laurance has received his PhD degree from University of California, Berkeley. In his very prolific career, he has written 8 books and over 500 scientific and popular articles. So without further ado, let me pass the floor to Professor Bill Laurance.
I'm going to talk about infrastructure, and I suppose in some sense infrastructure is not entirely silent because we hear a lot about infrastructure, but in many ways I think the impacts, the net effects of what's happening with this incredible tsunami of infrastructure expansion across the planet is really something that's quite remarkable and in many ways unprecedented. Sorry, it's Karen, excuse me, I apologize. Who introduced me? Karen is your name, right? Sarah, sorry, excuse me, Sarah. Sarah, sorry, mentioned this group ALERT. I did want to put in a brief plug for it. This is a group that we started up a couple of years ago because we wanted to have a forum for disseminating scientific information. We have a core group of about 3 dozen very eminent scientists. They're all fellows of the Royal Society or National Academies. Some of them are knighted. I mean, they're various distinguished scientists, but they're all people who understand that in the real world, the way that science sometimes addresses environmental issues has to change, and we have to be able to react quickly and decisively. So this is an organization that's all about really engaging in the real world. And we're currently we have readership of about 100,000 people a week now. So it's been quite successful. I mentioned I'm in Italy studying, I'm in Italy on sabbatical. One of the things I'm doing there is I'm working with a group that's trying to map all of the legal and illegal roads across the world's tropical and subtropical regions. And it turns out that is actually a pretty daunting job because there are so many, there's not just lots of legal roads, there's illegal roads proliferating everywhere you look. So I just wanted to mention that, and this is just about 30,000 people read that particular blog and that particular thing there. Now, why are we talking so much about roads and infrastructure? Well, we are living in the most dramatic and unprecedented era of road expansion in human history. For instance, the International Energy Agency suggests that we're going to have something like 25 million kilometers of new paved roads by the middle part of this century, and that's enough to encircle the Earth more than 600 times. And about 60% more roads than we have at present. And about 90% of those new roads are going to be happening in developing nations. Now, of course, developing nations need infrastructure, they need economic development, but of course they also sustain many of the planet's most biologically rich and environmentally important ecosystems. And so these roads have the potential to transform and change things in a lot of ways. There are, of course, other kinds of infrastructure happening, energy infrastructure, mining projects, hydroelectric dams. Everywhere you look, there's just some kind of new projects happening. It's a little difficult to try to disentangle the effects of one kind of infrastructure from another. For instance, there's currently about 3,700 hydroelectric dams of greater than 1 megawatt capacity that are either being built or are imminently planned to be built. And one of the things that you see, for instance, with hydroelectric dams, for instance, there's 334 major hydroelectric dams going into the Amazon Basin right now and into the adjoining Andes region. And the problem with the dams is not so much that they flood large areas, which they do, particularly in flat areas like the Amazon, but that they require road networks. They require roads for construction and maintenance of the dam. They require roads for power lines, that type of thing. And so what tends to happen is you get the dam being constructed, and these slides are quite dark, but that's the dam, and all this is secondary development that's happened as a result of the roads that have been established around the dam. It's been estimated, for instance, that the 12 dams that are going to come in on the Tapajos River, which is one of the major tributaries to the Amazon, those 12 dams are going to increase Amazon deforestation by about 1 million hectares above and beyond what will normally be happening over the next 15 years or so. So you can't disentangle easily one kind of infrastructure from another, because in many cases, things like these dams and mining projects and energy infrastructure and fossil fuel projects, logging projects, are providing the key economic impetus for road building. And the roads truly are transformative in the kinds of impacts that they can have. And just to give you an idea of this kind of scale, we're really not exaggerating when we say that this is unprecedented. It's a tidal wave of change that's happening. The G20 nations, when they met in Australia a little over a year ago, estimated that the developing world, or the world, needs between 60 and 70 trillion dollars in new infrastructure, and made some major commitments to try to see that kind of investment happening. If that happens, that will more than double the total global investment in infrastructure, and that's over the next 15 years. So we really are talking about some pretty profound kinds of changes happening. Just to give you one example here, is the Congo Basin. Of course, this is one of the second largest rainforest in the world. It's an area that I grew up thinking of as one of the great wilderness areas on the planet. In fact, when we look at some detail at the Congo, we see, in fact, there's a lot of roads. These are some of the more major roads in the Congo Basin. And even if you drill down here and look at higher resolution imagery, you in fact see that places that superficially don't appear to have roads actually do have whole little spider webs of logging roads ramifying through them that are not particularly big. Now, not all these are permanent roads. A number of these roads are not well maintained. A lot of them are not paved. They will, over time, erode, and some of them will collapse depending on whether or not they're being maintained or not. But the bottom line is there's an awful lot of roads in a place that we would consider one of the world's great wilderness areas. Now, I have a whole talk on road impacts, and I'm not going to do much at all on that. Simply just to say that I hope everybody realizes that roads change everything. Once you open up an area with roads, you change the economic dynamics, you change the human dynamics, you increase land speculation, you have an incredible array of different kinds of environmental effects. Obviously, you have some things like habitat loss, being one example of a direct impact. You have things like roadkill is another kind of direct impact, but even more important and more insidious than these direct effects are a whole array of secondary impacts that happen because you greatly increase the physical accessibility of the environment you're talking about. One of the things we see, for instance, is the incursions of hunters. Hunters are increasingly armed with much more lethal technologies, invading into places like Congo Basin, the Amazon, Borneo, many different parts of the tropical world. So instead of using traditional hunting technologies, they're using things like rifles and cable snares, that type of thing, which are much more lethal. And of course, there's fewer and fewer places for wildlife to hide because just about everywhere is being opened up by new road networks. And then roads, of course, promote things like deforestation and fires. This is a map of northern Bolivia. These areas in dark are major logging roads. The areas in red are major forest fires, and you don't have to stare at that very long to see there's a really strong correlation between where the roads are and where the fires are. This is some work that came out of Stuart Pimm's lab at Duke University. This is showing, as you get closer and closer to roads, this is the incidence in major fires, and this is in the Brazilian Amazon, as you're getting closer and closer to roads. This is even inside protected areas. We're seeing an increase in fire incidents as we're getting closer to roads. So again, roads are pretty dramatic and transformative in their effects. I'm going to talk about, I was wrestling with which talk to give, because I have one general talk on sort of global infrastructure expansion, and then some more recent work that we've been doing on Africa. And I decided to focus on the Africa thing because in some sense it draws in some more of the complexities, hidden complexities of the story that I think maybe are more close to the theme of the talk that we're focusing on now. Some members of my research group. This is Sean Sloan here. He sort of looks like a very rough motorcycle driving character. Actually, he drives a moped. This is Lin Fei Wang, who's a Chinese PhD student. She just finished her PhD that I was co-supervising. Very, very good student who worked in Africa and did a lot of work there, talking with a lot of Chinese investors and corporate representatives and others who are putting a lot of major investment into Africa. Jeff Sayer, who's an eminent expert on Africa and Indonesia, and he's the person who started up C4, the Center for International Forestry Research in Indonesia. And then recently, Bastian Bertsky, who's joined us as a protected area specialist, who's based at in Italy at the Joint Research Center there. Anyway, so that's sort of our team of efforts. Now, so here's Africa. We know that Africa is very diverse environmentally. Sometimes people don't appreciate just how big it is. It's almost twice the size of South America. So we're talking about, a very large expanse of land here in Africa. And there's a great diversity of different kinds of environments. We've got everything from lowland rainforests into some very rich and biologically rich and also very high endemism montane rainforests with really quite remarkable biotas. Very large savanna woodland systems, some of them hosting massive migrations, some of the last and greatest animal migrations on the planet. Semi-arid savannas, very rich coastal environments, probably some of the most important sea turtle nesting habitats left in the world. And things like some big lagoon systems and also swamp forests. Some examples of some of the habitats. These are the kinds of places, by the way, you do have to be fairly careful about some of the things like Nile crocodiles, which can be quite sneaky and hanging around some of these places. We also see some forest mosaics, which have been maintained and are maintained by burning. The Bantu tribesmen colonized a number of these areas 2,000 or 3,000 years ago, and so what you tend to get are these forest grassland mosaics. If you didn't have repeated burning, these would be mostly closed canopy forests, but the repeated burning tends to maintain these sort of mosaics of land use types here, and that's a pretty prevalent habitat type. Now, what we're really seeing in China in terms of, I think, some of the most dramatic effects of what's going on has been what's been commonly described as a feeding frenzy of foreign investment, primarily focusing on extractive industries, especially on minerals and oil and gas, and also to some degree timber. Africa has rich mineral resources, quite a diversity of things, and what we're seeing is an explosive growth in investments, especially from China, but also from Brazil, India, and also countries like Canada and my native country of Australia. China is currently investing, in fact, up until very recently, over $120 billion per year in various kinds of mining ventures. Australia is not immune here, too. There's been something like 150 Australian companies investing around $20 billion a year in more than 40 different African countries. So the other thing that we're seeing is so-called land grabbing, whereby foreign corporations or individuals are actually going in and buying up large tracts of land. There's been more and more land grabbing happening in Africa than everywhere else in the world put together. So, and this just gives you some idea of some of the mineral exports going on to China. So this tsunami of investment is going to change Africa. It is changing Africa, and it could potentially change it in a number of different ways. And I think that there are both sizable risks and there are both sizable opportunities that could potentially be exploited here. So in terms of possible rewards that can happen, obviously many of the governments in Africa are hoping to capture sizable amounts of rents, of investment that are coming in as a result of all this foreign mining investment and the exports of minerals. So that's a very important thing here. And also what we're seeing is oftentimes correlated with all this foreign mining investment is major increases in infrastructure, new roads, new railroads, new energy projects, new types of things that are associated, very oftentimes associated directly with extraction of the minerals. So for instance, we're talking about high volume things like coal and iron ore. A lot of these projects actually have to do with getting large amounts of coal and iron ore from, say, some of the interior areas of Africa out to a seaport where they can then be exported. There's potential, when you have these kinds of mining projects, to see some kind of funding coming in for mitigation efforts, for offset efforts, perhaps for purchasing new kinds of protected areas. There's, and particularly with some of the multinationals, a number of these do have fairly active programs trying to invest to a degree in some kinds of conservation activities. So there's non-trivial potential benefits that could be seized from this kind of mining activity at this scale. However, there's also considerable risks that could be associated with this. In terms of environmental risks, of course, mining projects can have quite large site impacts. Oftentimes they're relatively localized, but in that particular area, there can be very extensive, open pit mines and other kinds of activities. There can be substantial local environmental impacts. There can also be potential risks to aquatic ecosystems and to rivers because of spillage, of runoff of sediments and other things from the tailings from the mining operations themselves. Probably much more important than that would be the direct and the indirect effects of the infrastructure. The infrastructure is, in many cases, is threatening to open up various areas that are formerly remote, and simply by virtue of doing that, both the direct effects of the infrastructure, but oftentimes those indirect effects could potentially be pretty important. There's also considerable potential for encroachment into protected areas. We'll talk a bit more about this. And also in some cases downgrading. There's an acronym now that people are talking about called PADD, P-A-D-D-D, which stands for Protected Area Downsizing, Degrading, and something else. I can't remember what it all means. But anyway, the bottom line is, in many cases, existing protected areas are being shrunk, or they're being reduced, or they're being opened up because they happen to overlie some kind of valuable natural resource, oftentimes minerals. Now, there's a lot of issues that also, there's really significant concern about whether many African governments have the capacity, the governance capacity to handle this sort of flood of foreign investments, and whether or not there's the capacity not only to just capture the kinds of rents and royalties that would be produced, but also to distribute those in a socially equitable way. What you typically see happening in many countries where there's large-scale mining investments is a very unequal distribution of the rewards. There's certain people that tend to be well-connected and they tend to get very wealthy, and then there's many others that tend to be left behind. So and of course, the corruption issue is a very serious problem as well. It's well known, well characterized that not only is there considerable amounts of money being passed back and forth across the tables, but also underneath the tables as well. And sometimes that can facilitate decisions that would be unwise, that there would maybe be places where mining operations shouldn't happen, but because somebody's being paid off and becoming very wealthy, who's in a position of power, that type of thing just happens. Now, another thing that tends to happen, or can happen, and in fact it's quite a common syndrome, is this so-called, what's referred to as the Dutch syndrome. And it is a very common consequence when you see a large-scale foreign investment pouring into a country. And so when people tend to talk about all of these wonderful economic benefits of things like mining industries, one also has to realize that there's this other side of the coin. So for instance, when you get large amounts of foreign investment coming into a country, very oftentimes these are focusing on one or a small number of export commodities. Let's say, for instance, iron ore or coal, something like that. What then tends to happen is, because you've got this influx of currency, you tend to drive the value of your currency up. So there can be considerable increases in the value of the currency. So the problem with that is that greatly diminishes then the competitiveness of any kind of export industries, and also things like tourism and other manufacturing, those types of things that could basically be other important sectors of the economy. Education, if you are attracting people into your country for training at universities, you tend to lose out on those kinds of sectors. And so what tends to happen is we tend to see a destabilization of economies that become highly reliant on these major export investments, because what tends to happen is the pillar, oftentimes of mining, gets larger and larger, and the other pillars of the economy become weaker and weaker. Well, then what happens is a couple of things. One is that the economy becomes much more sensitive to shocks, because we know, of course, that there's fluctuations in commodity prices because of changes in supply and demand. We see this happening all the time. Also, if there's depletion of the natural resource, you can basically overexploit your resources, and then you have a boom and bust situation. The other thing that tends to happen is that unless nations have very effective governance and a very effective capacity to capture royalties and rents from those resources that they're exploiting, and then tending to distribute those across the society, what tends to happen is actually not a decline, but an increase in economic disparity, because goods and services become more expensive. There's more demand, living costs increase, food costs increase, and the problem is that long tail, the poorer people in the population, are the ones that really suffer. You get a relatively small sector of the society that's becoming, in some cases, very wealthy, and then you have this large component of the population which is really suffering, and that just becomes worse and worse for them. So the bottom line is, it's not all positive, and I think when we talk about mining issues, or we talk about these large-scale extractive industries, in these cases where we're seeing this feeding frenzy-like behavior happening, we're not just talking about the environment. We need to be talking about social issues, economic issues, about disparity, about economic stability in these kinds of contexts, because truly these are important parts of the story. Now, if we talk about what's happening in Africa right now, we're seeing, as we mentioned, even before this latest round of investment, we were seeing considerable road and infrastructure projects happening. We were seeing a lot of industrial logging happening, and particularly in places like equatorial Africa and the Congo Basin. We've seen quite a lot of slash and burn or swidden farming, about 1 million hectares of forest per year being converted from small-scale farming operations. And of course, we see a great deal of commercial and subsistence hunting, and increasingly much more commercial hunting, where the hunters tend to, again, be using more modern kinds of technologies, more lethal technologies, and oftentimes are much less selective than some of the traditional subsistence hunters would be. We've been working in hunting and roads and logging impacts in Africa for some time. This just shows you that the human population density of an area has a major impact on hunting activity. Where you get more people, you get more hunting. This shows an increase, strong increase in signs of hunting. So this could be things like logging camps and shotgun shells and snares and machete marks and boot prints, things like that, as you're getting closer and closer to villages and to logging camps. So when we get within about 5 or 6 kilometers of a small village or a logging camp, and this is in quite a sparsely populated area of the Congo Basin, that's in Gabon, you're seeing a big increase in hunting activity. So the distribution of people is a pretty important thing. So in addition to sort of this background of all this stuff happening, the other big thing that's happening in Africa, of course, is very rapid population growth. Africa currently has a population of about 1.2 billion people by the end of this century, according to the median projection of the United Nations Population Division. It's projected to have 4.1 billion people, so almost a quadrupling of the population. Obviously, this brings with it considerable concerns about food supply, about food security issues, that type of thing. So there's been a great deal of discussion in various kinds of international forums, the World Economic Forum and the General Assembly of the United Nations, other kinds of cases, about trying to increase food production in Africa. And one of the main schemes that's been discussed a lot has been trying to exploit some of these major areas in semi-wet and wet areas of Africa for increasing food production. And there is considerable potential for elevating agricultural production in considerable areas of land that could be potentially exploited. Now, it's not quite that simple. When we start breaking this down a little bit, for instance, we see that large areas, for instance, we see here, of southern Africa, in fact, are dominated by systems such as the Miamba woodlands, which tend to be fairly notoriously nutrient starved. So it's not that you can't do agriculture in these areas. It's just that you need large inputs of fertilizers, you need special kinds of cultivars, there's certain kinds of cropping systems that work and certain ones that don't work. We've seen there's Cerrado system, which is also supposed to be nutrient poor, in fact becoming very productive in terms of, in South America, being very productive in terms of soy and cattle production, for instance. So you can exploit these systems, but you're not going to do it with trivial amounts of investment. You need a considerable effort in sort of to try to develop some of these areas. So what's happening in Africa? Well, we have been spending quite a lot of time trying to ferret out information on a whole avalanche of major new infrastructure projects. And these are the so-called development corridors. These have been discussed now for almost a decade. Many of them are actually coming online or they're in the process of coming online. There's a total of 33 major development corridors that we've identified that'll pretty much crisscross most of sub-Saharan Africa. The backbone of each one of these corridors is typically a highway, in some cases a highway along with a railroad and also a pipeline. But basically they're designed to open up frontier areas, to increase agricultural production, and many times to access mineral resources that would be in some deeper interior part of the country. These are big corridors. The median size is about 1,200 kilometers in length. The largest of these is almost 5,000 kilometers in length. And in total, we estimate that they're going to be over 53,000 kilometers in length. That's a very substantial potential change in sort of the ecology and the environment in Africa. 14 of them are being planned right now, so they haven't been started. 9 are being upgraded in various ways, and 10 currently exist, although they're of varying levels of quality. So there's major upgrades and major kinds of improvements in those corridors happening. There's considerable potential for these corridors to facilitate agricultural production increases. This is a study done by our group in Australia where we looked at different kinds of cropping systems. This was led by the Chinese student Linfei Wang, and looking at different kinds of cropping systems that could be prevailing along some of these major development corridors. And of course there is a fair bit of agricultural potential. But one of the things that we wanted to do in our particular group is to say there's this whole set of different proposals, and they're being sort of rolled out and being suggested as being basically all a really good idea, that they're going to bring in major economic and societal benefits, and that they're broadly going to be widely supported. One of the things that they're going to, main reasons is that they're going to be increasing agricultural production. So what we wanted to do basically was to do, in a sense, a cost-benefit analysis to ask, what happens if we look at things like environmental values, if we look at human occupancy, and if we look at the likelihood that that corridor is going to produce actual, tangible benefits for agriculture. And also we wanted to know what kind of impacts it would have on protected areas within Africa. So that's sort of the gist of the analysis that we're talking about right now. Now, I've been involved in analyses of roads and infrastructure for quite a long time, done a lot of work in the Amazon, quite a lot of work in the Asia-Pacific region, and increasingly in Africa because of so many things happening there. A couple years ago, Andrew Balmford and I published a paper in Nature where we argued that the status quo, the way that we're studying road impacts right now, is just not working. Because what happens is, when somebody wants to build a new road, what happens is there's an environmental impact statement. And there's this very critical thing called the terms of reference. And typically what the terms of reference are is they say, what kinds of environmental effects are you going to get? And sometimes they're ridiculous. They say, on a 50-meter swath on either side of that road. Now, we all know, and this is actually some of the terms of reference for some of the major Amazonian highways that have cut right into the heart of the Amazon. Literally, the terms of reference were what's going to happen along the road route and also on a 50-meter zone on either side of the road route, which is pretty laughable. I also would say things like, if you happen to, with your bulldozer, you're coming along and there happens to be an endangered species in front of the bulldozer, you should pick the animal up and you should move it off to the side so that you don't run over it with the bulldozer. That is actually written in some of the environmental assessment and mitigation reports. So the point is this: nature, in many cases, is dying a death of 1,000 cuts. And trying to assess the impacts of these projects one at a time with these oftentimes very narrow frames of reference is simply not doing it. What we need is a much more proactive, much more sort of top-down and strategic attempt to say, where on the planets should we be prioritizing road building, and where ideally do we not want to see road building happening, and to look at this in a much more systematic way than this little piecemeal, bit by bit approach that's been happening. And so we made that suggestion. Of course, when you make a suggestion like that, then you're kind of obliged to do it. So we ended up a little over a year ago publishing another paper where we spent about a year with a very interesting multidisciplinary group. Had people from University of Cambridge, Harvard, Minnesota, James Cook University, a few other places working on this, a really good multidisciplinary group. And we basically presented a so-called global scheme, a global strategy for road building, which we said, this is on the, ideally on the planet Earth where you should and shouldn't build roads. Now, I'm not going to talk about all that, but I did want to give you a little bit of the general idea of what we were getting at and how that applies to this particular Africa context. And essentially what we're trying to do is two things. We're trying to say, firstly, where is it on the planet that we don't want to see new roads happening? And if you don't have to scratch your head too long to realize that there's some areas that are extremely environmentally and biologically important. And one of the key things that you realize, in fact, is it's oftentimes the first road into an area that's environmentally the most problematic, okay? Because really, in many ways, the first road is sort of planting the seed of the cancer. Roads and deforestation, or deforestation associated with roads, and cancer are a very good analogy. If we look at the spatial distribution of deforestation across the planet, we see that it is highly spatially contagious. And so what tends to happen is if you put in a new road, you tend to get deforestation developing along that road in a tumor-like fashion. And then what you tend to get is secondary and tertiary roads, and you get deforestation then spreading along those. And so in many ways, it's like the cancer metastasizes and spreads very much in sort of this tumor-like fashion. So in terms of cost effectiveness, if you can actually keep the first road out, that is far and away the most effective way to protect a wild area. But once the road goes in, then basically, and you're into a long-term investment in terms of enforcement activity, monitoring activity, that type of thing, in order to try to limit the impacts of those roads, particularly in many of these kinds of tropical frontier areas where the rule of law and where monitoring and enforcement are sometimes very limited. So those are the kinds of places with large environmental values, places that still have considerable wild characteristics that we don't really want to see roads going. So the second question is, well, where do we want to see roads? Where do we want to see roads being focused? And one of the key things that we decided to focus on was food demand. Firstly, food production, agriculture, is overwhelmingly the biggest human land use on the planet. We're currently farming an area the size of South America. We're grazing an area the size of Africa. According to current projections, we're roughly going to need to double global food production by the middle part of this century. And if we keep doing agriculture the way we're doing it right now, in a business-as-usual model, and this is based on David Tillman, who's an exceptionally well-respected agricultural scientist, if we keep doing agriculture the way that we're doing it right now, we're going to need approximately 1 billion hectares of additional arable land by the middle part of this century. That's an area the size of Canada, okay? So, I mean, that's an absolutely stunning additional amount of land to be having to add to the global agricultural system in terms of its environmental impacts. It just scares the bejesus out of people like me. So, now one of the things, however, is that if we look at the distribution of agriculture in much of the world, and particularly in many developing countries, what we actually see is large expanses of land that have already been settled. Most of the native vegetation has already been cleared, but that have quite low productivity systems. There's large gaps between what is currently being produced and what could be produced with more optimal agricultural systems. Oftentimes, roads, transportation, are one of the critical things that's missing from these particular contexts. It's very difficult and expensive to get fertilizers. It's difficult to get access to new farming technologies. And also, it's particularly difficult to get your crops in a cost-effective way to major markets, such as urban areas, without a lot of spoilage and without a lot of additional expense. And so roads are not the only component, but oftentimes better roads or new roads in areas that have already been settled are one of the most critical places where we really need to see road investment happening. And the other potential advantage of this is that if we do in fact see more investments in roads, new roads in these areas that have already been settled, we not only see increases in agricultural production, of course we also tend to see more rural investment, We see people getting better access then to health services, to education services. These areas become more profitable, they become more productive, and they may in fact begin to start acting as magnets and actually attracting people away from frontier areas, from forested areas where there's a lot of environmental damage, potentially focusing and concentrating them in these areas where we can see much more intensified agriculture happening and, in generally speaking, better human livelihoods, better lifestyles. So the general approach that we adopted here is to have a couple of different layers, a so-called environmental values layer where we look at some key environmental components, and then a so-called road benefits layer. I'll walk you through these quickly, and then we just sort of overlay these on top of each other and ask, well, what does the world look like when we do that? So here's Africa. Now, one of the reasons why we focused on Africa, this is a component of our global roadmap. I haven't shown you the whole planet here, just Africa, but you can see that we have 100 different colors here. As you move along this axis, as you go towards greener and greener areas, you're getting into areas that have higher natural values. I'll explain to you what we call natural values in just a minute. And as you move more and more into red areas, you get areas that have higher and higher agricultural potential with road improvements associated and other associated investments. As you get into areas that are dark, these are so-called conflict areas where you've got both high agricultural potential benefits and high environmental values. These are the kinds of places where we are anticipating seeing major conflicts, major difficulties in the future. And if you look at the continent of Africa, it's got more black than just about any place else on the planet. So this is one of the reasons why we really wanted to focus on Africa initially, was because of this relatively grim and alarming situation. There's a lot of natural values there, but there's also a lot of potential for conflict. So how do we get these two different layers? Well, the green layer, the layer that looks at our environmental values, has a series of components. One is biodiversity. So we're using global data sets here, which are the best available information. It's the best available data. It always makes me nervous to be using any kind of data set whose acronym is BAD. But the bottom line is these are the best data that we have available to us on a global scale right now. And one is the number of threatened vertebrate species, you can see here. Also, the plant species per ecoregion adjusted to the ecoregion size. We literally just put those two layers together, we average them, and we come up with a composite biodiversity map. And the greener you are, in essence, it says the more environmentally important that particular site is. Everything here is rendered at a 1 square kilometer scale, which means we had something like 133 billion pixels in the analysis. It was fairly computer-intensive analysis that we did here. Then we also looked at key habitats, things like biodiversity hotspots, of course, which are famous areas that have lots of locally endemic species that just occur in small places, and much of the native habitat's been destroyed. Important bird areas, key migratory sites, areas with endemic birds, the so-called G200 terrestrial ecosystems, which World Wildlife Fund developed, and high biodiversity wilderness areas. We literally just sort of smush those four together, and we come up with a map of key habitats. And then finally, environmental services. This is a map of losable carbon. This is, if you destroy the native habitat, let's say it's tropical rainforest, and you replace it with the local cropping system, let's say slash and burn farming, or if you're in Southeast Asia, it might be oil palm, it's how much carbon would be emitted to the atmosphere as a consequence of this. This other value right here is climate regulation. This turns out to be an interesting one because people really care about this. This is the impact of destroying the native vegetation on people living right at the local scale. So for instance, in Sumatra, we see that if we clear the native forest and we plant oil palm, we see on average almost a 5 degrees centigrade increase in temperature. Now, when you're living in an environment that's already pretty darn hot, 5 degrees of additional temperature is something that makes local people pretty uncomfortable. It has an impact on crops, has an impact on disease dynamics, it affects all kinds of things. So that turns out to be something that a lot of people are concerned about. So we put those two together into so-called environmental services layer, and then we just finally average those three different sets of layers into this sort of composite natural values map. This is our it's a very heterogeneous group of variables. I'm sure that if any of you sat down and did an analysis like this, you wouldn't get a map that looked exactly like this. But having gone through this exercise for quite a while, what I've been surprised about is really how robust the patterns are. There's strong patterns out there. There are some places of the Earth that when we look at things like biodiversity and critical habitats and environmental services that just come out as being consistently important and other areas as being less important. So That's the areas where ideally we don't want to see roads going because they have high environmental values. And if we look at the distribution of these environmental values here, we scale everything between 0 and 1. We can see, well, there's quite a lot of variation here. Quite a few sites actually come out with pretty high environmental values. Now, another thing we wanted to look at was human occupancy, because when we talk about the conservation potential of an area, not only do we want to focus on places that have high natural values, but also we want to focus on places that don't have very many people. Our definition of high conservation value is areas with lots of environmental values that are sparsely populated. Okay, these are the kinds of places where we would regard as being very important. So the best data set you can use on this are something called persistent night lights. That's where you get a repeated signature of a night light. Even something like a bright oil lamp is usually sufficient to be detectable. Because we used an extremely low threshold at this particular thing. There's probably some completely non-electrified local villages that wouldn't get picked up on this, but these are really the best data in terms of telling us where people are. Turns out, I'm not going to talk about this very much, turns out that you need to think a little bit about the spatial scale of how people are distributed and what the size of sampling plot you used. We compared a couple of very different 1 square kilometer pixels versus 500 square kilometer pixels, and we found out it didn't really matter very much which kind of pixel size we used, so we just used the smaller pixels. The bottom line is we think we've come up with pretty robust estimates of how many people are living along these corridors. And our definition, what we've basically done is we have this corridor. It could be up to 5,000 kilometers long or 1,000 kilometers long, and we put effectively a 25 kilometer wide or 50 kilometer wide Band-Aid right over the top of the whole kilometer, and so we're looking at that whole zone, that strip. And this is the average density or average frequency of people along each one of those strips. So one of the things we see here is that a few places have quite a few people, but a lot of the sites, in fact, are very sparsely populated. When we break it down even more, we in fact see many of the sites have less than 5%, less than 3% occupancy. So a lot of these sites just don't have very many people living in them. So when we put those two things together, when we define our areas of having high conservation significance, of being places with lots of environmental values that are sparsely populated, in other words, they're quite wild in nature, what we find, in fact, is that there's variability, but there's a lot of sites that actually come out with having quite high values. So it just says that there's a lot of environmentally important real estate in a place like Africa. Now what we want to do is look at the other side of the coin, which is to say, where do we want to put roads? Where are the best places to put roads? And so to do that, what we've done is we looked firstly at how much of the land's been converted. We don't want to necessarily put roads in places that have a lot of native vegetation existing. These are places where most of the native vegetation has been cleared. These are areas that have yield gaps, so there's a considerable gulf between what's currently being produced per hectare and what could be produced per hectare with better agricultural technologies. We're looking at the projections in agricultural increases. These are coarse data. They're produced at a national scale, and they're mostly associated with population increases. Most of these places that are showing big projected increases in food demand are because their populations are increasing, but in some cases also there's anticipated to be large increases in export markets happening as well. We're looking at access to markets. Even if you had all the conditions perfect for agriculture, you probably wouldn't want to start farming out in the middle of the Sahara Desert because you would still be, say, 1,000 kilometers from the nearest significant agricultural market, and it's just not going to be cost effective in order to try to get your crops to a market that far away. So that's another issue, is of accessibility. And then finally, soils and climate. We filtered things down if you were on nutrient-starved soils, if you're on really dry or highly unpredictable climates, those kinds of things bring all that down. Anyway, you put all that together, and this is a bit more complicated than the other map in the way that the data were put together, but the bottom line is you then end up with a map which says, where are the places where we could get the most bang for the buck in terms of new road investments? Where are the places where new roads or road improvements could have the greatest potential improvements for agriculture? And you can see there's sizable areas of Africa where that could potentially happen. And if we look at these road benefit values here, again, we see a lot of variability, but we do see some of these sites, quite a number of these sites, have high potential road benefits, but some of them also have quite low values. So there's a lot of variability. So what we can then do is we can put together the relative benefits
of road building with the relative costs of road building for each one of these 33 different development corridors, and we can say, well, how do they compare? And so here's our conservation priority here. We're moving over here. These are places, things with higher values here have got very high conservation priority. Things with high values here have high potential agricultural benefits with transportation improvements. And what you see is there's an enormous amount of variability. Not only is there an enormous amount of variability, there's no significant correlation between those two things. It implies that there's a lot of potential for trade-offs here. It implies that some of these things may be good ideas, some of these things may be bad ideas. They're certainly not coming out as all being quite similar. There's an enormous variation. So we've just done an extremely simple comparison here where we've used the median value on each axis, and we said, okay, if you're above the median value in terms of your conservation priority and you're below the median value in terms of agricultural potential, we're going to say those are inadvisable corridors. So there's about a half a dozen of them. There's about another 5 or 6 that are promising in that they have opposite conditions. They've got high agricultural potential and relatively low environmental values. And then there's a bunch of them that kind of fall out in the intermediate zones, either because they've got high environmental values or high agricultural potential, but not the other. And those we regard as marginal. And those are ones that we say, if they do proceed, they need to proceed with very careful mitigation and offset measures, because otherwise there's a great deal of potential for environmental harm to happen. Now, it is interesting, one thing that's very interesting here is there's 14 of the corridors are not even established yet. They're just being planned. They're still on paper. If you look at those 14 planned corridors, you actually see that they have significantly lower agricultural potential than the other corridors. So that also says something to us. We said, are all these corridors really a good idea? We're talking about major new investments going into these sites that are supposedly being designed to increase agricultural production. Well, a lot of them are going to be going into places that are not really looking that great for agriculture. If we sort of map these things out using our promising, our marginal, and our inadvisable colors here, there is a pretty strong geographic pattern here. What we really see is that the corridors that look like they're a bad idea are pretty strongly concentrated in equatorial Africa. We're talking the greater Congo Basin, we're talking West Africa, and we're talking a lot of these very wildlife-rich savanna woodland systems and eastern arc forests here, the Montane Rainforests. So these are the reds and the blacks. The greens tend to be coming up in some of the more subtropical and temperate systems and areas where there's already been quite a lot of land development, where you already have significant human populations, that type of thing. But the bottom line is, and this is an admittedly coarse level of analysis, we really want to drill down now and start looking at this in even more detail using finer spatial scale data sets, is there appears to be enormous variation in the efficacy and the advisability of a lot of these different projects. Some of them look like they should just never get off the drawing board. But in fact, there are major interests in many cases, major commercial interests, government interests, and others actively pushing for these. And the argument many times, even though mining is oftentimes the key thing that's providing the economic impetus, the argument again and again and again is we need to increase food production. Well, in fact, the environmental costs in many cases are going to be extremely high, and the potential benefits are going to be questionable at best in some cases. Now, the other thing we wanted to do is we wanted to see what would be the potential impacts of these development corridors on protected areas in Africa. There's a little over 6,000 existing protected areas in Africa. And so what we did is we looked at the intersection of the corridor with the protected areas. And so we looked both at where would the corridors actually cut right through, literally bisect the protected area. And we also looked at where would there be, within this 25-kilometer wide, or it's actually 50-kilometer wide zone, but 25 kilometers on either side, where would be the overlap of this zone of influence with the protected area? Because in these kinds of areas, we could see increasing hunting, increasing agricultural development, isolation of protected areas, more encroachment in protected areas. There could be a whole set of impacts that could potentially degrade the quality of the protected area. And what we found is, not terribly surprising, there's a pretty strong relationship between how long the corridor is and between how many protected areas it's going to impact. Okay, so longer corridors are going to affect more protected areas. Not very surprising there, but it is interesting when you start looking then in total what the net effect of all these protected areas could be, and what you see is that over 400 of the protected areas in Africa would literally be cut in two, if not by one, sometimes by more than one corridor project. Okay, so if you put one of these major corridors right through the heart of a protected area, clearly you're going to have major impacts on that area. The other thing is that if we consider that broader zone around the protected areas, that over 2,000 protected areas could potentially be affected. That's nearly a third of all the protected areas in Africa. And about 40% of those are high priority sites, things like World Heritage Sites, Ramsar wetlands, UNESCO Man and Biosphere Reserves, that type of thing. So we're really talking about a set of projects that could profoundly change the conservation landscape in Africa, very probably in an irrevocable way. It's also interesting, if you look at the corridors that are currently being planned or upgraded, they tend to be more dangerous in the sense that they're going to impact on more protected areas than are the corridors that already exist. So we've got a whole set of kind of indicators of warning signs, red flags here, which are saying to us, wow, we need to stop, slow down here a little bit and think about this. Now, the one bit of good news in this whole thing is we've seen recently, of course, a decline in a lot of commodity prices. Of course, China's economy is slowing down. This is having effects on the global economy. Iron ore, copper, many other commodity prices have dropped. Surely this is temporary, but it is perhaps giving us about 10 seconds of breathing space to try to say, my goodness, we need to get in, we need to critically evaluate projects like this, and we need to try to get in better environmental planning, better land use zoning, better mitigation efforts, and we need to try to improve the governance capacity of a lot of the nations that are going to be absorbing and are attempting to manage these truly unprecedented investments, because if we don't, it's going to be a very serious set of problems for Africa. So, in conclusion, a lot of the corridors have high conservation priority. Two of them are absolutely off the charts. Two of the corridors are just no-brainer bad ideas, should never happen. 6 of these high conservation corridors have only modest agricultural costs, and I think you can make a very strong case that at least 6 of the corridors probably should not happen at all. And then there's a bunch of these marginal ones that are questionable, and perhaps some of these should proceed, perhaps some of these will proceed, but they have to be done in a very careful manner. So a few of the corridors, 5 or 6 of them, clearly are good ideas and will have considerable benefits relative to the costs. But the bottom line is, this wave of corridor building is likely to have profound and really, in many cases, irrevocable impacts on natural environments in Africa. It's no question that Africa is going to be profoundly altered if this whole avalanche of projects proceeds. So, thank you.
Yeah, okay. Thank you very much, Bill, for this very interesting talk. Now, you have taken the time now, what the situation is now. And we all now know that we go into a climate change age. And that will drastically affect the rainfall pattern.
Yes.
And agriculture is, most of the agriculture is still rain-fed agriculture. So large part, if you start the agricultural activities in this area, you must be sure that also in the next 30 to 50 years, actually the scenarios indicate that you will have at least enough water to do it.
Yeah. And as it turns, I mean, Sasha, that's an extremely important point. And it turns out that, if you look at global general circulation models, which are our tools that we use for predicting the future, rainfall is one of the things that we're least confident about. If you put a gun to a climatologist's head, force them to give you an answer, they'll say things like, well, wetter areas are probably going to generally get wetter, drier areas are probably going to generally get drier. But when you talk about downscaling, which is, we want to know whether Arusha, Tanzania, or Sao Paulo, Brazil, whatever, are going to have more or less rainfall in the future, our capacity to predict is incredibly tenuous. And the way that this frustrates me, the way climate scientists tend to get around this is they tend to lay whole bunches of different big complicated computer general circulation models on top of each other, and they average them, and they call them ensemble models. And oftentimes these models are wildly different. And they say, well, we're just going to look at the average, and that's going to be our best guess of what's going to happen in the future. And it turns out there are some places on the planet where there is more consensus, but there's also other places where there's very little consensus. Now, your point is
very well taken because, in fact, a lot of places, for instance, our global analysis suggests that the Sahel region is an area, when you look at costs and benefits, has significant potential for agricultural development with improved transportation. But the Sahel is also notoriously high in terms of interannual rainfall variability, and also many of these systems can be tipped very dramatically in the savanna woodland systems, one direction or the other, by relatively small changes in either the total amount or the seasonal distribution of rainfall. So this is something in the 2014 Nature paper, we did emphasize that these kinds of models need to be done at finer scales, and one of the things you need to do is to try to bring in the best available information. But the bottom line is, it turns out we have a much better, we still have considerable limitations, but we're considerably better at projecting future temperature changes than we are at projecting future rainfall changes. And rainfall is really important for agriculture, for hydroelectric energy, for nature, for human societies. It's just critical, and we're playing dice with the future of the planet.
I think the regional climate change model, that's a huge effort, and you have kind of spotty around the globe areas where it is done. The rest is all statistically downsizing.
Yeah.
And with all the problems which go with it.
Yes, the downscaling is an enormous problem, and most climatologists will readily admit that. One result that does seem to be pretty robust, and this is done only at global scales, is if you look at projections of climate extremes like heat waves and droughts and major flooding and rainfall events. Most of the scenarios project significant increases in those in the future. But critically, they don't tell us where, and they don't tell us when those events are going to happen. Just it's likely that we're going to get more. So again, we're trying to plan for, the latest UN population projections suggest we could have 10 to 12 billion people. You keep hearing this number 9 billion, that's not the latest number. It's 10 to 12 billion people by the end of this century, and the population will still not have stabilized, and that's based on the best and most recent median projection of the United Nations Population Division. So, as I often say, I'm very frustrated that we don't talk more about population issues, because the difference between a world with, say, 9 billion people versus, say, 11 or 12 billion people is enormous. And in terms of stability, in terms of migration issues, in terms of conflict, in terms of food security, in terms of environment, the stakes are incredibly high. We really need to be we need to be careful how we talk about these issues, and that's another. Somebody else wants to talk about the language of population, that's a whole different set of things. But I'll stop here. Yeah, turn it over. Yeah.
Question here?
Yeah.
So first of all, let me just say thank you for doing this work. It's really, it's incredibly important. My first sense on this is that at a global level, what you're talking about is basically trying to concentrate the human populations. And it kind of reminds me of the drive for urban density. I'm from the Seattle area, and that's a big focus. And so I guess my question is, when I think about like this concept of leapfrogging technology. So there may be a country that doesn't have to invest in its telephone infrastructure, the same kind of poles and things. They can just go straight to mobile. My question is, are there things that we're learning today from urban density and similar types of sustainability planning in the more developed world that might be applicable in Africa, so that they could actually design for urban density in a very different way than, say, what we've done in the rest of the world?
That's an interesting question. I've been asked a few questions in my day. I've got to confess, I don't think I've gotten quite a question like that. A few things you can say. Urbanization's happening everywhere. We're seeing massive increases in urban area and urban footprint. The expert on this, in my view, is Cairns at Yale, who's done a lot of modeling on the growing urban footprint. Available evidence doesn't show any kind of watershed that I'm aware of. There's a lot of people talking about urban planning these days and urban ecology and things like that. We see some scenarios where there have been some very novel practices brought in, but I would say the average scenario is bigger cities with bigger sprawl, with more traffic, with more of those really deadly micro pollutant particles. They're not necessarily healthier or better places to live, and yet we're seeing more and more people, you know, the urban footprint and the need to feed these hugely growing urban areas is increasing dramatically. Africa, in fact, actually lags behind the other major developing regions of the world in terms of the urbanization trends. There's still very large rural populations in Africa, but nonetheless, we will still see, for instance, in West Africa, there's going to be really enormous growth in the footprints of cities. So, I mean, that's a good question. I would almost turn that back to the audience and say, I mean, obviously, the cell phone technology would be an example of where 30 years ago, people said, oh, we've got to put in all these new phone lines, we need to do all that, and we've leapfrogged that. There's amazing things coming online all the time. There's something called, in terms of conservation, there's something called Global Forest Watch now. We now have, thanks to a collaboration between University of Maryland and Google and NASA, what is effectively becoming real-time monitoring of deforestation almost everywhere in the world. That's incredibly important. We've got so much data coming in, what we're limited by is people to interpret the data. And so, you know, but that's revolutionized things. And I could talk some length about Brazil, where I've lived for quite a while, about how that technology has changed law enforcement. It's brought a level of law enforcement that was completely out of control in a lot of frontier areas. So it's not really addressing your question of urban things. I mean, really the most environmentally effective way for people to live is in large skyscrapers. If you want to minimize the footprint, put them in large, you know, skyscrapers and try to avoid urban sprawl, and probably think of more sort of nucleated cities where people don't have to be driving 45 minutes to an hour and a half, wasting gasoline and producing the carbon emissions and making everybody unhappy in order to get into some kind of urban center. So there's lots of language around this, none of which is particularly my area of expertise. I think it's a huge growth area, and I think it's an area where we really do need to think about, because the truth is we're going to have a lot of really big cities in the future. And some of them may not be particularly healthy places, nice places to live, yet nonetheless people will be living there. Yeah. Yes?
Let me say first how much I am impressed, stunned almost, at the amount of data that you're able to put together and the very intelligent way you've framed it. It's an impressive piece of work. But I'd like to, for a minute, put this in a historical perspective. Let's drop back 150 years into North America, where I think the Santa Fe Trail and the Oregon Trail would qualify as what you're calling illegal road building.
Yeah, probably, yeah.
And the end result of that is, I don't believe you even look at North America. Am I correct?
Not here, but in our global map, a global analysis, we certainly do look at North America. Yeah, we look at everywhere, yeah.
So I'm suggesting that in another 150 years, there won't be anything to study here in Africa or South America either, because there isn't much in North America anymore.
Well, yeah, I mean, I'm hopeful. One can certainly adopt a pessimistic viewpoint, and I do sometimes say to people, if you want to see Africa, I would go sooner rather than later. I mean, there's the pressures and the scale. They're talking about maybe putting a major road across the Serengeti. I mean, that's going to affect one of the world's greatest, surviving wildlife migrations, for instance. You can be glass half full or glass half empty. I think in my line of business, if I'm going to be glass half empty, I'm probably not going to be able to keep going much longer. And so I have to try to have a ray of hope behind this and hope that we can seize on as many opportunities as possible. For instance, a lot of these corridor projects get proposed and they get, what we're trying to do, we've just gotten some support from the foundation who really wants us to look in more detail at these corridors. And to start focusing on, we're going to start focusing more on the reputational and other risks to corporations, to governments, to international donors and lenders, which are behind a lot of these projects, as well as major mineral corporations, and say to them, you know, a bunch of these projects probably shouldn't happen at all, and sometimes they don't get off the drawing board. So I think it's not hopeless. Yeah, yeah. But has North America been changed dramatically? Whew, absolutely. And have roads and railroads transportation been at the heart of it? Yes, just like everywhere else. Absolutely.
Could I ask, who has the decision-taking capabilities for these proposed development corridors, and and what are the possible avenues for negotiation to build on the research that you've described?
Yeah. Well, it's interesting because there's a whole set of actors, and it ranges from major mining corporations to governments to foreign investors to the international donors and lenders. There's a number of bilateral, for instance, European-African initiatives. I mean, there's a whole complex set of actors. There is a group called the Integrated Resource Development Corridor Initiative, which we're interacting more, which includes representatives from a number of NGOs, as well as the British Overseas, DFID, and other USAID and other organizations. I think that's something that we're really trying to do now, is broaden our contacts within Africa and try to figure out where the pressure points are. Now, I've been working in tropical forest conservation for close to 35 years now, and we have actually seen some amazing things happen. And I have to say, we've done more with sticks than we have with carrots. You know, you'd like to lure everybody along with these nice carrots, and everybody, sticks actually tend to be a lot more effective. And one of the things that we've seen, just to get a little bit tangential, is an enormous number of so-called no deforestation agreements, moratoria, other things, particularly affecting things like oil palm corporations, wood pulp corporations, some of the cattle ranching and soy that we're seeing in the Amazon, different things, as well as a number of the major consumers of these commodities, such as Nestle, Cargill, Procter & Gamble, others. They have basically come out and said, because it's become almost politically incorrect not to say that we're not going to sell or produce products that result in deforestation. Now, a healthy sense of cynicism is necessary in having these conversations, but in fact, the behavior of a number of these corporations is changing and has changed. And in some cases, they're partnering with NGOs who are working with them on monitoring and compliance. And it's actually gotten to the point right now where, for instance, in places like Indonesia and Malaysia together produce 85% of the world's palm oil. They are actively trying to destroy the no deforestation agreements on a couple of different grounds. One is that they say it impinges on their national sovereignty, and Indonesia alone wants to clear 12 to 14 million hectares more of native forest for oil palm and for wood pulp plantations. And they also say and this is partly true, it disadvantages the smaller producers because there's costs associated with the compliance with no deforestation and monitoring, et cetera, and the small producers don't understand it and don't have the resources to put into that. Now, it turns out the entities that are putting these kinds of coalitions together are working very hard to try to bring the smaller producers online to make it feasible for them to do it and to be cost competitive. But the bottom line is the reason that they are fighting this is because it's actually having a positive effect in terms of slowing deforestation. We're seeing the same thing in Brazil, where very powerful rural lobbies and industrial lobbies are now fighting what's called the forest code. I mentioned something about Brazil. Brazil now has real-time monitoring of deforestation as well as cadastral maps. In other words, who owns what piece of land. It's all mapped out. So if there's suddenly fires and burning or bulldozers happening over here, and they can go, boom, there's no permit for clearing over there, and they run in. Turns out you don't actually have to arrest very many people or find very many people, just a few people, and suddenly word gets around, and people realize, wow, the government's actually serious. So now what's happened is a gigantic fight in the Brazilian Senate and Congress to try to overturn the forest code, because now suddenly, for the first time in ever, it's actually being enforced. So what are they doing? They're trying to basically cut the legs out from under the code, just like Malaysia and Indonesia are trying to destroy the no deforestation agreements. So these battles are being fought, the stakes are very high, and in some cases there are wins happening. I think we have to focus on the pressure points, you know? And I'll just say a little bit more about this. This thing about these no deforestation agreements, you know, you might think it's really hard to get a corporation to do this because you've got to convince them. The reason they do it is because of the reputational impact they get hit, but they lose market share. Asian Pulp and Paper is the poster child for this. Nobody wanted to touch them because they just became so toxic. Their reputation became so toxic. But what happens now is a small NGO can go to a corporation and they can say, look, you are producing all this products made from old growth, you know, planking and timber flooring and furniture, et cetera, from old growth rainforest timbers. And if you don't stop doing it, tomorrow morning we're going to have grandmas and little kids and TV stations, or we're going to be postering, you know, all your major retail chains, and they're going to be saying, this corporation, you know, you're killing baby orangutans, and we don't want that to happen anymore. And guess what? That actually gets the attention of some of these corporations. So surprisingly, it's about finding these pressure points. And as I said, I think the sticks have actually worked better than the carrots in a number of cases. Steve. Steve.
Could you say just a word about plans for road building in Montana? I think I've heard you say it may be the most critical managing plan on the planet.
Yeah, so right on your doorstep, I'm sure you're all still wheezing from the haze from this last burning season, much of which has come from central and northern Sumatra. So there's really two places, and Sumatra's been decimated, as you know, so many other, Borneo, large areas. But the last part of Sumatra, the last place in the planet where orangutans, tigers, elephants, and rhinoceros still coexist is in this place called the Lucer ecosystem in Aceh province in northern Sumatra. There are plans right now, there's this notorious thing called the Aceh Spatial Plan, which is going to punch about 400 kilometers of new roads called the Ladia Galaska Road Network right through the heart of this really the last surviving wild places in Sumatra, aside from some of the more remote places up at the high elevations. So the last lowland forests will be decimated, and I mean, it'll just exacerbate, of course, it'll exacerbate the haze problem and all the other things going on as well. But one of the most biologically important parts of the world is slated to be profoundly affected. This road network will change everything. It'll just slice up, and basically you can probably write off most of the lowland forests in this area and a number of other areas because of hunting, because of various kinds of oil palm and other development that will happen, rice and other things in these areas.
Okay. So yeah, just to follow up on that, because I worked in Lucer in the late 90s. I worked in the Congo Basin in the mid 90s. So yeah, these are very near and dear to my heart, and thank you for your talk and for bringing this up, and especially for pointing out the work that NGOs are doing. It's stunning to me. You know, I've been on and off fighting Ladia Galaska for 14 years now, and it seemed like it was going away, and now it's back, and that's just appalling. But I want to turn it to something that hopefully is a little bit more promising. Want to get your take on it. So just starting this year, the new UN Sustainable Development Goals are really talking about trying to do a lot more integrative looks at development and sustainability, including conservation. And so, you know, we have goals that talk about improving food security, and we also have goals that talk about preserving biodiversity and terrestrial ecosystems. Do you think that those can be used as leverage, especially against the governments, the funding agencies that are talking about this, to say, look, you know, all of these countries have signed on. We've said that this is the direction that the world wants to go in now. How realistic is that that dream that I have that maybe this is actually going to start working?
Yes, I would like to believe
that, I mean, for instance, one important part of the Sustainable Development Goals is the Aichi objective, which is saying that we need 17% of the world's ecosystems in some kind of protected area, which you actually tend to find is that a lot of protected areas tend to get stuck in kind of remote, low-value areas. And so when you really start breaking it down, looking more at an eco-regional level, you see many places are very poorly represented. What do I really think? I don't know. I mean, I look at it the same way as I look at the recent, I was in Paris at the UNFCCC conference, and there was a commitment there made to limit global warming to 2 degrees and hopefully to 1.5 degrees. Do I think that's going to happen? Not in 1,000 years do I think that's going to happen. I don't believe it for a moment. Do I think we need to be aspirational and try to set these kinds of goals? Yes. Do I think we need to use them as leverage to try to influence? And some governments can and will be influenced, and others simply will not. Yes. So I think having the human development goals, the integration idea is important because we do need to much better integrate the approaches. What we see happening now is much more chaotic in many areas. The development that's happening, it's opportunistic, it's illegal in many cases, it's unregulated. There's very little, if there's space, I don't even know how, I start to lose my capacity to articulate into words, because if you look at some of these spatial plans, like even places where you have so-called spatial development plans, look at Indonesia. I mean, the scale of what they're talking about doing will just rip the heart out of the environment. I mean, the 6 so-called development corridors, all of which are kind of turned into spider webs of new roads, will just, this is a national development plan? I mean, basically that's a plan for, it's a plan for environmental chaos. So, there's a real need for serious strategic land use planning that goes from the regional level down to the local level, and I think you're quite right that there needs to be much closer integration of development schemes, human welfare, and then at local and landscape scales. But it's a real governance challenge. And well, you could use Indonesia as an example where you've got multiple layers of government and a lot of difficult, complicated actors. We, as conservationists, we are living in the right time, and we have no shortage of work cut out for us. So, complicated answer to a pretty complicated question, really. Yeah, but good question. Yeah. I don't think the mic's on there yet.
Thank you. I'm just curious. I just happen to know that Singapore is doing research on underground cities.
Mm.
And I was wondering if you could also do underground roads and for mining or whatever, to preserve the ecosystem. Are people thinking about that? Because of course it will be more costly.
Yeah.
But then if we are so involved, we could help.
Yeah.
Right?
That's an interesting idea. I mean, obviously, let's say mining. There is subsurface mining, and then there's surface mining, and it's cheaper to go in a coal reserve where you can just literally just rip the top of the mountain off and to have a big open pit mine. But there are plenty of mineral deposits that are underground. And the notion of building cities underground is an interesting one. I mean, you'd certainly save on your your insulation and your electrical costs and things like that, because there could be some profound savings there. I suspect that the initial investments involved in terms of just constructing, I mean, imagine the reality of building a city underground, plus just the vitamin D supplements we probably all have to take because they weren't getting any sunlight. That type of thing. I mean, there's a whole, I think it's an interesting idea. I frankly wonder whether it would ever be implemented on a particularly large scale, except perhaps in some really unusual circumstances. I mean, yeah. Not saying it's not a good idea. It's just one of those ideas that, yeah, is. I just think there'll be a lot of costs involved in it, quite frankly. Yeah. Yeah.
Yeah, I wanted to follow up the urbanization discussion. If I understand your work, it's in reaction to the roads that are already there, rather than talking about what could be there.
Actually, no. Yeah.
I mean, okay, that's fine. Let me just proceed with the question.
Yeah. Okay.
So I was surprised. I thought it was a fantastic piece of work, but it struck me as odd that the biggest phenomenon that's going to be happening, which you've already mentioned, is population growth and urbanization, and that wasn't mentioned in the body of your talk, given that that is going to be one of the major drivers for some of the highways that are eventually going to kind of be like a spider web across Africa, with maybe 3 more billion, 5 more billion people coming on board.
Yeah.
So I was wondering whether in that work, whether you'd actually considered it as something. So but I also have another question.
Let me just I like to do them one at a time, if you don't mind. So, in fact, the projections in population increases are incorporated into the model, into the road benefits model, because there's a layer that looks at projected increases in food production needs. And that's substantially based on population growth projections. It also incorporates projected increases in agricultural exports. So that's brought in at the best. Unfortunately, those data are national scale. Now, there are other things one could bring in, and Karen Cito's work, as I mentioned, Karen has attempted to model the increasing urban footprint across the world. And I think, one could try to bring that in. In fact, one of the things that we've grappled with in putting together this kind of analysis is, if you think about it, there's an almost infinite number of different reasons why people will build roads. And so what we focused on is the overwhelmingly biggest human land use and probably need, which is food production and agriculture. But people build roads for lots of other reasons. And if you try to incorporate, sometimes people build roads for territorial reasons. India's major road building right now in the Arunachal Pradesh area doesn't really have to do with any kind of rational development. It has to do with trying to defend their frontier with China. Brazil's original roads in the Amazon were because they were very concerned that Colombia and possibly even the United States were going to try to come in and annex the Amazon. So there's a very wide variety of motivations for road building, some of which are kind of economically rationalist and others are all over the map. But the problem is, if you try to incorporate every single one of those into some kind of global scale analysis, you end up with something that's so complicated, this whole notion of error propagation. You start adding more and more things and you end up with something that's kind of, I think, unmanageable. So there's a level of complexity where we felt like we went about as far as we were able to go, and then anything beyond that we felt like might be a bridge too far. But anyway. Your next question.
Well, actually, just to follow up to that, did you in any way try to understand where the urban centers are going to be growing in Africa? I mean,
yes.
Incorporated. So that was part of that analysis.
Well, again, Karen Cito has mapped for the entire world the projected footprint of all cities. I can't remember if there's a 50,000 threshold or not, by the year 2030. So that map exists, and we've looked at it for Africa, and there are certain places, and particularly West Africa and some of the eastern arc areas in eastern, more equatorial Africa are showing like increases. We did not explicitly incorporate into that, but we did have the latest available data layer, which is from 2010, which says what is the travel time to the nearest city of at least 50,000 people. And depending on where you are, that can be by car, it can be by foot, it can be on the back of a donkey, it can be anything. And it's actually calculated, and they're going to redo another one of these for, I think, 2015 data, but we did use the latest, best available data for how long it would take you to get to a city, which is going to be your major market for your agricultural crops today. One other thing I have to really, important caveat I have to make is that our current maps of roads around the world really suck. The best data sets we have is something called G-roads. Now, it's okay for some countries. You know, Switzerland, I think the roads are mapped beautifully, I suspect in Switzerland. And I'm sure in Singapore, they're probably beautifully mapped. But you go to the Democratic Republic of Congo, you go to Brazil, you go wherever you go, what you find is two things. One is you find a huge number of roads that are illegal and have not been mapped. So they don't exist on any maps. We did an analysis for Brazil. We found almost 3 kilometers of illegal road for every 1 kilometer of legal road. The other thing is that what you get is great variation among different countries in road map quality. So anytime you want to do any kind of real major large-scale analysis, you're dealing with these really confounding problems with data quality, which is one of the reasons why I'm on sabbatical right now, why the European Union is actually paying for me to be in Italy, because we're attempting to map all of the legal and illegal roads across the world's tropical and subtropical regions, and we're using a combination of Google Earth and crowdsourcing. So we're literally going to have thousands of human eyes, which turn out to be better than our best available computer technologies, using this very standardized approach to map all these roads out there. Once we have that, we know, for instance, getting me off on one of my many tangents, we know that once we really know where the roads are, we can be much more precise in terms of how we project impacts. For instance, 95% of the deforestation in the Brazilian Amazon occurs within 5.5 kilometers of a road. And boom, you can take that to a bank because we've mapped all the illegal roads. Once you start doing that, you really get these very strong, you much better understand where human impacts are happening and where they're going to happen in the future, but you need the good maps. And right now, we just don't have good maps of where the roads are.
Now I have my second question.
Okay.
Which is a technical one, which may be totally irrelevant. But you had this very nice summary of, acceptable, not acceptable, etc. And that came from an analysis where you had, I don't remember, 4 or 5 categories, biodiversity and so forth,
yes,
which you analyzed sort of, as I understood it, the way you presented it, sort of independently. Each one was done within its own kind of category. Yeah. And what I was wondering about, and you sort of alluded to it a little bit, was how you combine those.
Yeah.
And that's a highly non-trivial, there must be enormous assumptions in that because they're a priori all highly coupled systems. I mean, so, how you did that is a little bit tricky. So I wonder if you could just expand on that and to try to justify, and why I say maybe I could imagine that at the kind of coarse graining that you're doing, maybe it's not so relevant.
That is a very good question. In fact, the most heated debates we had among our research team revolved around 2 things. One, which global scale data sets to include in the analysis, which ones do we trust or have the most trust in? And secondly, how do we combine them together? And I can tell you there was a little bit of blood on the floor after some of these discussions because there are different ways that one can integrate them, and there's different sets of logic. There's about 20 pages of supplementary information in the paper, which actually describes in a lot of detail why we chose the data sets, what their assumptions are, how we combine them together, et cetera, et cetera. But you actually put your finger on a truth, which is that there's more than one way to measure what we might call natural values. And so what we basically tried to do was to use a multifaceted approach, but not all of those data sets, strictly speaking, would be independent of each other. For instance, if you looked at the distribution of threatened vertebrate species, you would find that probably is fairly coincident with global biodiversity hotspots, okay? And there's some other, you in fact find these intercorrelations. Now, these different data sets do tell you different things. And it is interesting that once you start stacking these things on top of each other, for instance, carbon storage actually correlates quite well with total species diversity, which tends to correlate pretty well with locally endemic species, with, et cetera, et cetera. It is interesting that these things kind of start
self-reinforcing. And even though there's to some degree, overlap, I think each one does tell you something different. And what it really says to me is there's a surprising amount of robustness in the patterns. We could have used a different set of parameters, and I think we would have gotten something fairly close to what we ended up with. Not exactly the same, but we looked at enough combinations of variables in enough ways that the patterns, there's certain kinds of systems that are just really biologically important real estate. Tropical and subtropical wet and humid forests, isolated mountain ranges, some island systems, some Mediterranean systems, some of the higher latitude forests, just again and again and again, come out as being more important than some other places.
Okay, so this has been a very engaging topic, certainly, and it's been a very, very thought-provoking presentation by Professor Bill Laurance. However, we're running out of time, so we shall conclude the presentation here, and if you have further questions and comments or suggestions, you could carry on after this session. Okay, so I would like to invite everyone to join me to put our hands together to thank Professor Bill Laurance for a very engaging presentation, and we would like to present him with a token of appreciation.
Notice this is a thumbs up symbol. It's very, very hopeful and optimistic. So.